Have you ever noticed how electricity prices in your home country are different from other places in the world? Can you think what might cause this difference? How would the variation in the energy mixes of different countries affect this? The objectives of today's session will be to understand how regional difference in energy generation portfolios can affect the electricity prices. In addition, we will compare the different portfolios and prices of some EU countries. We have already seen the supply and the demand curves for electricity markets. We learnt how the intersection of these curves defines the market price, which in turn defines the quantity of electricity traded. Now, we're going to make things a bit more complicated by comparing the supply and the demand curves of two different countries. First, we'll start with country A. The energy mix in country A is made up of a large share of renewables. You can see this in the supply curve because the production units A1 and A2 are priced at €0 per megawatt hour. These are renewable generators, for instance wind turbines or solar panels, which do not have a marginal cost. Then we add the demand curve, here represented by the red line. We can use this to find the market clearing intersection, which gives us the price PA for electricity in country A. Because there's so much cheap generation, you can see that PA is quite low. Country B, however, has a more classical energy mix, consisting mostly of coal and gas-fired generators. In the supply curve, you can see the costs of B1 to B6 are relatively high. When we add the demand curve, this determines the market clearing price as PB. Notice here that PB is higher than PA. The difference in the energy portfolio between the two countries results in country B having a higher electricity price than country A. So the type of production portfolio within a country impacts the average market price. More renewables means lower marginal costs and lower prices, whereas more thermal plants like coal and gas typically means higher prices. Let's look at some real-life examples. Here we show the generation portfolios for 4 countries: Germany, the UK, Spain and France. This is data from 2018. On the vertical axis we have the generation capacity, measured in gigawatts. A gigawatt is 1,000 megawatts. The amount shown represents the installed capacity. This is the maximum possible power that could be generated if all plants were available and were operating at maximum capacity. In reality, this doesn't happen. The demand is usually much lower than this. Most countries have too much generation capacity, which is needed to ensure there is always sufficient capacity available to match consumption. Firstly, we'll look at the coal generation of each country. Traditionally, coal was the main source of baseload power in the countries such as the UK or Germany. We can see that Germany still has a large proportion of coal in its energy mix. Nevertheless, its share has decreased significantly as the country has introduced more renewables. In the case of nuclear, France is one of the biggest players. France has a lot of nuclear power in its energy generation portfolio, and this will impact the prices. In recent years, however, the share of renewables in each country has increased significantly. In fact, renewables now account for over 30% of electricity generation in many EU countries. Remember though, that despite the large capacity in countries like Germany and the UK, these plants will not operate at maximum capacity all the time. So the contribution of renewable energy sources to actual electricity generation is much lower than shown here. But how do these differing generation portfolios affect the electricity prices in these countries? On this slide, we show the average electricity prices in different EU countries in 2017, measured in Eurocents per kilowatt hour. This is shown in dark blue. A large part of the energy price is composed of taxes and network fees. You can see these represented by the light blue bars. As you can see, the average electricity price in, for instance, France is rather low, only around 17 cents per kilowatt hour. This is impacted by the large share of nuclear power. whereas in Germany, with a large share of thermal power generation, the average costs add up to over 30 cents per kilowatt hour. You can see that there are low-cost and high-cost countries in each depending on the energy mix. To finish off, I want to show you what a real merit order looks like. Here we have the merit order for a country in 2 different years. On the left is the country 10 years ago with a traditional energy mix. On the right is the same country nowadays, with a high share of renewables in its system. The colours represent different technologies providing electricity. On the left of each graph are the low marginal cost units, like renewables and nuclear energy. On the right, we have the high cost units, lignite, hard coal, natural gas, and fuel oil-based generation. Of course, the precise shape of this merit order is dependent on the marginal cost of each of the units. Once again, you can compare the 2 graphs and see how the increase in the share of renewables shifts the supply curve to the right. This also impacts the average price of electricity because the demand remains the same, resulting in lower average electricity prices. What's the energy portfolio like in your home country? Does it contain a large amount of coal and gas, or are renewables a big contributor? And how does this reflect on your home electricity prices? Something to think about for later.